we have already looked at the inverting amplifier, which is shown in this circuit here. And the inverting amplifier has an output which is equal to minus R2 over R1 times Vn. So what I'm going to do is, instead of at the place of Vn, I'm going to put a power supply here. Okay, and let's say I'm giving an input of Vin. So what is the output going to be? As I just said, it's going to be equal to minus R2 over R1 Vin. Now, what I want to ask is, what would be the current that would go into this circuit? So if I apply a voltage of V in at the input, how much current would go into the op amp? Okay, so let's try to work this out. So if I want to work the current out, what do I know about the voltages? Now I know that the voltages at both the inputs of an ideal op amp is going to be the same. So here the voltage is 0. So the voltage here also should be 0, right? So the voltage here is 0. Now, I know the voltage at this point, it is 0. And I know the voltage at this side of the resistance, and that is V in. So I can write an equation for I in, right? So what's the voltage drop across R1? It is V in minus 0 over R1 should give you I in. So let me write that. So I get I in equal to V in minus 0 over R1, which is equal to V in over R1. Now, if I want to say what is the resistance that is seen by V in on this side of the circuit. So let's say this V in, so whatever is on this side of this line is like a black box to this power supply. Okay, and what would be the equivalent resistance of this entire circuit? So in other words, what I'm asking you is, if I wanted to replace this circuit with a circuit like this, so that's Vn, and I say that what I want here is just a resistor which is going to ground. Okay, so I'm replacing the circuit that is on the right hand side of this yellow line with just a resistance, and I'll call it Rn. Okay, so what is this Rn going to be? And of course the answer is that if the current is In and the voltage applied is Vin, then Rin is basically equal to Vin over In, right? And for our circuit for the inverting amplifier that we have here, this Rn is going to be again Vin over In, and Vn over In, you can see from here, is going to be simply equal to R1. Now this Rn is called the input resistance or input impedance, to be more general. Input impedance, or you can also call input resistance. Now, what does this input impedance or input resistance tell us? The input impedance or input resistance is telling us that if we apply a particular voltage at the input, how much current is going to be drawn, right? So this entire circuit, this entire inverting amplifier can be replaced by a resistance equal to its input resistance as far as this power supply is concerned, right? So it will tell you how much current is being drawn here. So now let's look at the input resistance of the non-inverting amplifier. We know for the non-inverting amplifier that if we apply a voltage of V in at the input, then the output is going to be equal to 1 plus R2 over R1 times V in, right? So what we are asking is, what is the input current going to be? Now, if you remember, one of our assumptions for the ideal op-amp model was that the current that flows into the input terminal is going to be zero, right? So the current that flows here is going to be zero, and that's the same current as I in here. And therefore, the answer is simply that the input current is going to be zero. If that is the case, what is R in going to be? R in is V in over I in, and that is then going to be infinite for the non-inverting amplifier. So for the non-inverting amplifier, we have this I in. So let me just write non-inverting here, because I am going to put the value for the inverting amplifier here. So for the inverting amplifier, what was my Rn? My Rn was equal to R1. And for the non-inverting amplifier, my Rn is infinite. Now what does that mean? What that means is, just think about this. This power supply here does not have to supply any current, or I mean in real life very, very small current, so that you can get this output, right? But in an inverting amplifier, the current that would need to be supplied would be given by I in equal to V in over R1. So there would be a finite amount of current that this supply would have to supply to the inverting amplifier so that it can give the output that it gives. So in the non-inverting case, the power supply has to give almost no current, while in the inverting case, a significant amount of current needs to be supplied by the power supply. So some power is going to be drawn out of the power supply so that the amplifier would work in the inverting case. However, in the non-inverting case, the power that is drawn is almost equal to zero. Okay. Now, whatever source that we put here should have the capacity to give the power that is being required by the amplifier. If it is not done, then it will be loaded. Okay. So think of the non-inverting amplifier here as a black box, and you apply a input of V in and you get an output. Similarly, for the inverting amplifier, you give an input and you get an output. But that's where the similarities kind of end, because there's a current that is going to be drawn by the non-inverting amplifier when an input is connected. And how much is that current going to be? That is going to be In equal to 0, as we have already seen. In the inverting amplifier, how much is the current going to be? The current is going to be In equal to V in over R1. So the power that is being drawn from the source here is much higher than what is being drawn from here. And therefore, this power supply needs to be able to supply this much amount of current or power. While this power supply, the requirement of the current that it needs to supply or the power that it needs to supply is much smaller. Which means that the non-inverting amplifier is not going to load the power supply, right? And while the inverting amplifier, there is a chance that it may load the power supply. What do we mean by load? We have already talked about it. By load, we mean that this power supply here, V in, will not be able to supply the current that the inverting amplifier requires. So one of the major advantages of a non-inverting amplifier is that there is no loading. Okay. In other words, the current required is very, very low, which is what we have indicated here. While in an inverting amplifier, there is a chance that loading can happen, and that's not a good thing. Of course, the other difference is that in a non-inverting amplifier, the gain cannot go below 1, right? 1 plus R2 over R1 Vn, and therefore the gain is always above 1, while in an inverting amplifier, you can have a gain of less than 1 as well.